Are you concerned about securing electric utilities and power grids against vulnerabilities and threats? Have you ever thought about how to defend it against operational disruption and attack? If you answered yes to these questions, then join us for this BlackHat session, The Future of Securing Intelligent Electronic Devices Using the IEC 62351 Standard for Monitoring. The session will be at 9 a.m. on August 8th. The World Economic Forum's Global Risk Report, released in January of this year, states that attacks to critical infrastructure is a top 5 global risk. And according to the U.S. Department of Energy's multi-year plan, the energy industry is #1 in reported cyber incidents. In the past, the main focus for industrial organizations was to implement reliable equipment, but focusing only on reliability can create challenges later on, such as lack of authentication control, encryption, and robustness, passive grid monitoring technologies, limited visibility, and unreliable vulnerability assessment. And as attackers continue to increase in sophistication, new challenges arise by things like the shortage of security skills, immature security processes, and the convergence of IT and OT environments. More recently, the industry has been adopting monitoring solutions to improve threat detection and increase visibility. This has been a drastic improvement for securing critical infrastructure, but it's still not enough to respond to the latest threats. Understanding the unique protocols used in ICS environments is one of the most critical parts of securing industrial systems. Those protocols are responsible for retrieving information from field equipment and for sending control commands. They rarely incorporate any security measures, including security against errors, equipment failures, or deliberate sabotage. Critical infrastructure is an attractive target because every country has them. It is for this reason that Workgroup 15 actively develops cybersecurity standards for industrial networks. With the IEC 62351 standard, Workgroup 15 puts forth a series of effective solutions to create secure communication channels inside critical infrastructure networks. The standard addresses multiple security objectives such as encryption, data authentication, spoofing prevention, and intrusion detection. Part 7 of the standard defines data objects, which are required to increase asset awareness and security against advanced threats. Largely used management protocols like SNMP make it possible to collect critical information on the assets, thus increasing the visibility and status of the network in a reliable and safe way. Due to the value provided by this approach, several manufacturers have invested in the development of this standard and have made sure that their products are compliant. Security solutions capable of interacting with IEC-compliant equipment help to extend network protection to include additional threat scenarios. The biggest advantage is the drastic improvement in asset health monitoring. For example, alerts can be raised for faulty or overloaded devices, which could represent an emergency situation. Having information about the internal status of equipment allows engineers to prevent disruptions. In fact, in most cases, evidence of the issue exists long before the disruption occurs. Knowing the status of network also helps to detect advanced attacks against targeting the internal logic of the devices. For example, ladder-based attacks, where the attacker modifies the behavior of the industrial process, like the CPU load or memory usage, provides indicators that can trigger an investigation. Furthermore, attacks have the potential to cause physical results, such as power outages and damaged equipment, and could lead to a very dangerous situation. IEC 62351 Part 7 helps by offering detailed information about power supplies and network cable status. So come join us and learn about a new active monitoring approach designed for industrial networks. This approach is being used in real-world environments to help security engineers respond effectively to today's most advanced threats. We look forward to giving you a glimpse to the future of power grid security.